Hello everybody. Today we'll be speaking about the concept of recursion. Recursion consists of solving a problem through smaller versions with the same property in order to solve the bigger problem. The function calls itself and it creates a loop, which is terminated once you can solve the problem in a single step. This leads us to the next part, the parts of a recursive function. A recursive function consists of a base case, which is the simplest problem inside the recursion, and a recursive call, which is a part of the function that calls itself back. Recursive problems can be solved with the SSS strategy, which means to first simplify the expression until the base case is reached, second substitute the base case, and third solve until the final answer is found. Additionally, recursion can also be called as the divide and conquer strategy. This is where you take a big problem, divide it across smaller problems in order to reach a bigger solution. And one real-world example of a recursion is a family tree. A family tree demonstrates recursion because it can be a big tree full of a lot of family members, but it consists of smaller families and smaller branches, which get smaller every time. And it's just like a real life tree, which is full of smaller branches each time. The members at the top are the head of the family, and every branch under is also the head of its own family. Each branch refers to the past branches, and then it works its way back to the top until you reach the oldest person in the family tree. Here, we can see a demonstration of recursion because this clock, every time that the arrow keys move, it calls itself back, and it keeps going. Hello everybody, now for our final example, we will be working through a piecewise function. The piecewise function that we will be working on will be f of x equals f x minus 2 plus 2 if x is greater than 9, or f of x equals 3 if x is less than or equal to 9. Now, in order to solve this, we must apply the SSS strategy, which means that first we're going to have to substitute f of 17, which is what we're trying to find. Now, we're going to work throughout the process of f17 minus 2 plus 2 since it's greater than 9, and we're going to work all the way down until f of 9. This is going to take us 4 iterations of the same function in order to get from f17 to f of 9. Now that we know that f of 9 is equal to 3, we can work our way back to the top, add everything up, and we will get the answer for f17. So 3 plus 2 plus 2 plus 2 plus 2 is equal to 11. And this means that f of 17 is equal to 11. Now, our computer does it for us as well, but I'm going to leave the work up here on the screen to show you how we use recursion to walk through this piecewise approach. Thank you very much for watching my video on 12.8 recursion.